So I'll be talking a little bit about regenerating shortleaf pine today, and I'll be talking about both artificial and regeneration. So it's a little deviation from your schedule, but I am going to try to cover both of those. So start off with a couple of pictures, revisiting some of the topics we've already covered today. Be honest with yourself. When you're working in the forests of North Carolina, which picture more closely resembles what you see day to day? The one on the right or the one on the left? For me, it's oftentimes the one here on the left. Very dense conditions, lots of small understory and mid-story stuff that's just waiting to sprout the minute you go in there and do any type of harvesting or any type of other treatment in there. You know, a lot of times when we describe our stand densities, we just look at the big trees out there. So we might say, oh, there's 250 trees per acre, when in reality we might have 2,000 or 3,000 stems per acre, each one of those just waiting to sprout once we do something. Whereas historically, most people would suggest that we had more open stand conditions. If we look at it from another point of view, same stand looking upwards, which is more common? One on the left or the one on the right? Again, for a vast majority of us, unless you're working exclusively in longleaf in the sandhills, this is probably what you're dealing with most of the time. So based on these things, what we're actually seeing is that the management practices that we typically do are no longer creating the conditions necessary for shortleaf pine to regenerate on the landscape. So looking a little bit deeper into some of that same forest inventory and analysis data that we saw on in earlier presentations, what we actually see is that the ratio of overstory trees to understory trees is way out of balance. Less than 10% of our shortleaf pine, as of 2007 numbers, is in age classes under 20 years old. A vast majority of our trees are overstory trees, and they're starting to fall out of the overstory and not regenerate themselves. So what that points us to is that we need to start putting some serious thought into regeneration-focused management if we're going to maintain shortleaf pine and bring shortleaf pine back on some of the sites in which it historically existed. We're certainly not the first people to realize that there are some issues with the shortleaf pine ecosystem being reduced in acreage. And we're also not the first people to acknowledge that we don't actually know that much about regenerating this species. Historically, we've treated it like loblolly pine, and in many cases that's been to our detriment. Past reforestation or natural regeneration efforts for shortleaf pine have oftentimes failed when we just use our typical loblolly pine reforestation techniques. So there's actually been quite a bit of work done on this though, which is pretty fortunate. And pretty much what I'll be doing today is giving you guys a lit review of what has come out of some of the past efforts on learning more about shortleaf pine. So there was a symposium on the shortleaf pine ecosystem done in Arkansas. There was actually a group that focused exclusively on regenerating shortleaf pine, and they put together a several hundred-page document covering all aspects of regenerating shortleaf pine, and then touching on some of the more recent literature that's come out on shortleaf. So today, I'll start off by talking about where to establish shortleaf pine. The question of what is a shortleaf pine site often comes up. Then transition into natural regeneration, speak about artificial regeneration, and then close with some an overview of what we just covered and some discussion points. So as we talked about earlier, shortleaf pine has an expansive native range. I realize it is a site-specific species, but the thing is if you look at it, it has a range of about 440,000 square miles is what that actually calculates out to. And it can grow on all sorts of different sites. There's a difference between where it can grow and where it actually has a chance to achieve dominance. But it can grow on all sorts of different types of sites. But instead of focusing on where we could grow it, because that's expansive, I would recommend we focus on where it should be growing, where it actually has a chance. So, what makes a good shortleaf pine site? This is a question that came up during the planning of this meeting, and I was asked to identify, the best shortleaf pine site. Well, the best shortleaf pine site are fine silty loams and fine sandy loams, which you typically find on a floodplain, very deep, well-drained soils. On more upland sites, it likes deep upland soils, sites that tend to be a little bit more acidic, and it doesn't like high levels of calcium. The problem is that those site conditions also adequately describe where loblolly pine, red maple, and other competing hardwood species also do really well. Those species grow quite a bit faster than shortleaf pine, at least early on. So when you plant shortleaf on these types of sites, yeah, it'll grow really, really well. There's an example of a tree I'm not really sure where, oh, I guess it's Mississippi, Nuxabee Wildlife Refuge. They'll grow really, really well on the right site. Unfortunately, so does everything else. So where should shortleaf pine grow? I'd recommend where it actually has a chance to achieve dominance. If you plant it on one of those other sites, you risk spending all of your time and money fighting everything else that also really wants to be there. So there's a couple of different factors that we can use to try to pick out a shortleaf pine site where you have a higher degree of success or a higher chance for success if you artificially or naturally regenerate this stuff. Slope position and aspect. Shortleaf pine tends to be able to maintain dominance on upper slope positions, ridge tops, and on slopes with south-facing aspects. There's quite a bit of research that's been done on that. That is where you have your harsher, drier, less fertile conditions, and shortleaf pine has a competitive edge over some of the more water-loving species. When we look at soils, it tends to like the well-drained soils with clay-textured subsoils. Thing I will point out though, when we're talking about soils in North Carolina, keep in mind that we've lost anywhere from 25 to 75% of our topsoil at this point. So in many cases, our subsoil is now our soil. So you can look at the soil maps and try to pick out some sites that way. Unfortunately, sitting here and identifying specific soil types in North Carolina is a little bit beyond the scope of what I can actually get into. Another thing, somebody brought up Little Leaf earlier. I unfortunately don't have time to address that. There is a hazard rating system out there. I would recommend, if you're thinking about regenerating shortleaf, pull out the old, I believe it's Copeland and Wilson from 1954, Little Leaf hazard rating. You can look at your soil type, figure out if it's a low, medium, or high hazard. If it's a high hazard, you may not want to plant shortleaf pine on that site, because in 20 years you might start running into trouble. It's all about putting the right tree in the right place. When we look at elevations, it can technically grow up to about 3,000 feet of elevation in this part of the country, but where it tends to do well is between 600 feet and 1,500 feet of elevation, which is pretty much the Piedmont. So these are areas where shortleaf pine actually has a chance. So now I'm going to get into some of the regeneration methods. I'm going to explore both natural regeneration as well as artificial regeneration. The thing is shortleaf actually responds well to both of these things. Both of them are perfectly good options. I'm not going to try to say one's particularly better than the other. They're both pretty much just paths towards the same goal. So natural regeneration. I realize about a third of the room is foresters, so there's a couple of definitions straight out of your silviculture textbook. I didn't feel too bad doing that, acknowledging that many of us may not have actually cracked our silviculture textbook in over 10 years. So there's a couple of definitions in here. Just bear with me on them. But straight out of the Dictionary of Forestry, natural regeneration is the establishment of a plant or a plant age class from a natural seeding, sprouting, suckering, or layering. When we talk about shortleaf pine, we're paying attention to natural seeding and sprouting. Keep in mind with that basal crook, sprouting is something that we could use to our advantage here. Some of the work that was done back in the 80s by the Shortleaf Pine Regeneration Working Group, I believe is what they called themselves, they identified what they called the 4 cornerstones of natural regeneration of shortleaf pine. Those consisted of, you need adequate seed production. You need to have enough seed being produced. Once that seed is produced, you need to have a receptive seedbed on which that seed can fall. Additionally, you need to make sure that it's on a soil type that is going to maintain appropriate moisture and fertility and rooting ability and all that for those seeds to actually germinate and begin to grow. Once they begin to grow, you need to make sure that you have adequate competition control to give shortleaf pine that jump start that it needs to actually start growing up and be free to grow and start growing upwards into the forest. So I'll explore each one of those a little bit. Seed production. Seed production for shortleaf pine takes place over about a 3-year period. That means there's about 3 years where something like a hard frost or insect damage or a hailstorm or something like that can knock out your seed source. So it's a tough thing to work with, but it does produce seed. It perpetuated itself on the landscape for a long time, so it is possible to rely on natural seed. Seeding generally begins around age 20 for shortleaf pine However, if it's a vigorous tree, tend to be growing out in the open, they can actually start producing seed quite a bit younger than that. That is rare though, but there is some documentation that trees as young as 9 have produced viable seed. Seed fall generally begins in October, peaks in November. It's mostly done by December, but you still will see some seed fall as late as April, but it's minimal seed fall. So keep that in mind whenever I start talking about some of the reproduction cutting methods on later slides. Seed fall, if you have your seed fall, most of the research suggests that you need about 50,000 seeds per acre to have enough natural regeneration to consider that a success. So you need a lot of seed falling from those trees in order to result in an adequately stocked shortleaf pine stand. The seed falls of this level typically only occur about every 3 to 6 years. That's a southwide average though. There's some other research suggesting that around here and further up north, it's actually a wider span than that, more like 4 to 10 years. So it's not nearly as frequent or prolific as another species like loblolly pine. So on sites where you have shortleaf and loblolly growing, you have to take that into account that loblolly is probably going to be throwing a lot more seed on those sites. Once you have the seed, if you look at dispersion, it can disperse about 300 feet downwind, but in all other directions, it's usually limited to about 75 to 100 feet. Is that showing up back there at all? No? Okay. So the receptive seedbed is the next thing. Like the other southern pines, it requires bare mineral soil on which to fall and germinate. There's a couple of different things that we can do to help bring along that receptive seedbed. Site preparation burning is a big one, and I'm going to try to touch on that as being a good one over and over again in this presentation, but later presentations coming up are actually going to touch on fire more, so I'll hit it lighter, I guess. Scarification is another technique that you can use. And if you can't use fire, if you have some smoke management issues, there's other things you can do. I've seen some studies out in Missouri and Arkansas where they just get a tractor to drag an anchor around out in the woods. Tears up the top layer of litter and exposes bare mineral soil, and they have used that to establish some shortleaf. I've also seen some people locally drag old tracks from bulldozers around to do the same thing down in longleaf areas. Oftentimes though, just the harvesting operation itself, if you do a clear cut or a seed tree or shelterwood harvest, that exposes enough bare mineral soil to successfully regenerate this stuff. And that's what I was trying to show here on the bottom, is that's following just a normal timber harvest, and we've got about 90% of the bare mineral soil exposed there. Competition control is the next cornerstone. Good seed beds for shortleaf pine are also, unfortunately, really good seed beds for other species that grow a lot faster than shortleaf pine. So here's a picture of, this is more of a seed tree level retention in a hardwood stand. That's 2 years later, and that stuff's about 6 feet tall. All that thicket of regeneration. Pines generally don't want to grow underneath something like that. So in most parts of North Carolina, the minute you open up a stand like that, this starts happening, unless you do some other work in the meantime. Here's another stand that we recently opened up. That's 1 year after harvesting. So we're already starting to get a lot of regeneration coming back. Competition control is essential, and it can be accomplished a number of different ways. Temporarily, through things like prescribed burning. If you have a long enough history of fire, I guess you can really start to knock it back, but generally it's going to take several rounds of fire to really start to control a lot of these sprouting hardwoods to any large degree. Selective herbicides are another really good method that you can use to start to control the competition, and mechanical methods like brush sawing. And oftentimes combinations of all three are the best way to go. So now I'll get into some of the reproductive cutting methods. First one I'll talk about is the clear cut method. Now again, bringing up your silviculture textbook, I'm talking about the clear cut regeneration method, not going out and clear cutting something and then hoping for the best afterwards. This is a deliberately planned clear cut harvest. And it utilizes one of two different ways to regenerate, either the seed in place or the seedling in place. And both of them require very precise timing to be successful. The seed in place basically involves harvesting while the cones are mature but not yet open, so before October. You go in, you take out the overstory, you leave the top wood and the branches and everything like that on the site, and what this does is, come October, those cones open back up and drop seed onto the bare mineral soil. If done correctly, this has been used successfully in the western part of the range to regenerate shortleaf pine stands. An alternative to that, and many sites that I manage probably wouldn't be suitable for this, and I expect most of us are in the same boat, but some of the areas like Rob's managing where he's been burning for a decade at this point, seedling in place might be an option, where you have bare mineral soil exposed and you get a bumper crop and you end up with a carpet of shortleaf pine growing up underneath it. By summertime after that adequate seed year, you have that carpet, come in and take out your overstory, you'll destroy a vast majority of those trees, but hopefully you're going to end up with a couple hundred that are spared once you take out that overstory. And that also has been successfully used to regenerate shortleaf pine stands. These clear cuts don't necessarily have to be huge, expansive cuts either. You can use strip clear cuts, and if you're going to do strip clear cut for shortleaf pine, most of the research suggests that they need to be about 300 to 400 feet wide, spaced out in 5-chain intervals. You can't make the strips too big because of the limited seeding distance for shortleaf pine. Keep in mind, it's 300 feet in one direction, only 75 to 100 in the other. So that 300 to 400 is kind of right in line with that. Then your blocks and groups, just don't make them too big. So blocks 8 to 10. Patches, never could find an official definition of a patch, except that it's probably larger than a group but smaller than a block. They also don't necessarily have to be perfectly square shaped. And in fact, with most of the conservation goals which would be guiding us towards managing shortleaf, you may not want perfect squares out there on the landscape. I'm going to save time, skip over the pros and cons. We acknowledge clear cuts look bad. So here we go. Now, some of the other reproduction cutting methods here, we've got the seed tree cut and the Shelterwood cut. Both of these rely on standing trees to provide the seed for natural regeneration, but they're different in the residual densities and also the purpose of those overstory trees. So in the seed tree cut, in shortleaf pine, that typically consists of leaving about 10 to 12 square feet of residual pine basal area. And I highlighted pine because I'll touch on that on a later slide. But you can usually accomplish that by leaving about 8 to 20 well-spaced, large diameter shortleaf pine trees. That's usually enough to provide the adequate seed fall to regenerate underneath the seed tree system. And those trees are left primarily just to provide that seed. That's what they're there for. There's no expectation that they're going to provide any sheltering effect for that regeneration. On the other side of that is the Shelterwood harvest, which is just higher residual basal area left on that site, typically between 30 and 40 square feet of residual pine basal area, accomplished by leaving 30 to 50 trees. Also large diameter and well spaced. In addition to providing that adequate seed source, the Shelterwood system, a lot of the research shows that it does quite a bit for the understory seedlings. It provides quite a bit of shelter, thus the name. I'll touch on that on the next slide. Just kind of a comparison between the last two. The seed tree and the Shelterwood. We've got seed tree on the left. It's obviously more open, and both of these pictures are from Oklahoma. So this isn't anything we've done locally. Obviously more open, whereas the Shelterwood's over here. They did some studies out in the western part of the range, and what they ultimately found is that underneath the Shelterwood system, there was less solar radiation, cooler air temperatures, cooler soil temperatures 3 inches down, which is kind of a big deal for young establishing seedlings. They tend to like that top layer of the soil. Higher relative humidity, so a little bit less desiccation, lower wind speeds, and honestly, the amount of regeneration was more consistent underneath the Shelterwood system. So most of the research that comes back on this suggests that if you're going to pick one of these regeneration methods or reproduction cutting methods, Shelterwood tends to be the way to go based on what we know so far. That being said, all this stuff comes from the western half of the range. I'd recommend we start trying some of this stuff out in North Carolina and see what happens. But like the clear cut method, these regeneration methods oftentimes create seed conditions for other trees that you don't necessarily want out there. So it's not a one and done type of situation. Oftentimes you still have to come in, do a fair bit of competition control, do some pre-harvesting work as well. You might need to do a pre-cut to open up the stand before the regeneration harvest to give your residual leaf trees a chance to expand their crowns and increase cone production. You might also want to do some prescribed burning in the meantime. to start creating that nice receptive seed bed prior to taking off the overstory. All right, so naturally regenerating mixed stands. I was asked to talk about this, and unfortunately, we don't have a ton of information on this, at least not deliberate attempts at it towards some targeted species composition like oak, hickory, shortleaf. At least locally, we don't have that much about it. It's possible, there's been research on it, but here's a couple of major points to consider that have come from that research. When we look at reproductive cutting methods, they can work. So they've looked at seed tree, shelterwood, group selection, single tree selection, and basically what they have found is that single tree and group selection harvest does not usually result in a large enough disturbed area or adequate light conditions and low enough competition for shortleaf pine to become established. So those methods tend not to work. And that's important to point out because if you look in some of the recommended things for some of the, I guess, ecologically significant areas on which we have shortleaf, recommendations for single tree selection and group selection tend to be pretty common, but the research suggests it hasn't really been that successful. Seed tree, shelterwood, and clear-cut methods have been successful, but in almost all those cases, it's required quite a bit of site preparation work, quite a bit of competition control, quite a bit of prescribed burning, and combinations of those techniques to be successful. If you just leave it alone, you ultimately end up with a thicket of regenerated hardwoods or loblolly if that's in your system, or mixtures that you don't necessarily want. The other thing to point out is that light conditions are quite a bit different. So if you're going to do a shelterwood cut, you can't just say, okay, well, it's 30 to 40 square feet of shortleaf pine, so I need to leave 30 or 40 square feet of oak hickory, and it's the same thing. Some of the research that's come back shows that for every 1 square foot of hardwood, that has the suppressing power of 2 square feet of pine. So you can't just take the same residual basal area levels and transfer them between those species mixtures, or else you end up with different light conditions. They actually quantified it differently and found for basal area X on one site, and it was uneven aged, but we could still pull some information away from this. On site, or on basal area X, it ended up being 60% light intensity under just a pine-only canopy. For that same basal area X, it was only 25% light intensity when it was a mixed stand. So now I'll get into some artificial regeneration. Definition: an age class created by direct seeding or planting seedlings or cuttings. I want to point out the word plantation does not show up in the definition. So when you talk about artificial regeneration, we're not just talking about planting monocultures of shortleaf pine. You can do mixed species plantings. Things don't have to be in straight rows. It's just another means towards establishing new trees. I point that out because sometimes artificial regeneration is accused of just being plantation management. Not always the case. The thing that I like about artificial regeneration is that it gives you a couple of things that you can control, or at least influence. One, the species composition. You can plant mixtures of different species and end up with different species compositions long term. You can also control the stocking. You can determine exactly how many trees per acre you plant out there. You can save yourself the trouble of having to come in and do an expensive pre-commercial thinning later on, which you probably will have to do under a natural regeneration plan. You can also control the timing of establishment, which as a public lands manager, I need to plant things. I need to space out my reforestation projects so that I have a pretty consistent, I can afford everything every year. But controlling the timing of establishment is also valuable to our non-industrial private landowners. Also, you can control the quality of the regeneration. There isn't really time to get into this today, but I'd encourage you each to go home and read about hybridization in shortleaf pine. The rates of hybridization of shortleaf pine with loblolly pine are much, much, much higher than you would think. So check that out, read about it, but if you do some artificial regeneration, you can actually make sure, if you track down the right seed source, that you're actually planting pure shortleaf pine on some of these sites and not planting in something that's, you know, half loblolly. So what it really comes down to, based on the literature, it comes down to site prep. When you're talking about artificially regenerating shortleaf pine, site prep, site prep, site prep. And there's a couple of different things that we need to touch on. I realize that's going to be an interesting one, but given the slow early growth of shortleaf pine, what we typically end up having is the need for an extended period of time of competition control, and site prep can give us that. I'm going to touch on ripping, prescribed fire, and herbicides. So, acknowledging that generally when you're going to plant shortleaf, there's usually some type of conservation goal in mind. Ripping is a step in what many would view as the opposite direction of that. I acknowledge that. However, the research that's come back on ripping makes a decent case for it on some sites. It fractures the subsurface hardpan, and you can do it in a clear cut, which is evidenced by this probably D8 ripping through a clear cut right now with those shanks. What they have found is that it ultimately reduces soil bulk density. It improves water movement in some of the more poorly drained sites. It also has been it's been shown to be best done in combination with other things. Like this site, for example, this was burned, but probably could have benefited from some other stuff. You can actually see that it's dragging a tree underneath the ripping shank there, and that can result in an inferior rip. But it's best done in combination with other things. But let's look at the research. Out in Arkansas, by ripping and planting in the ripped rows, they were able to increase survival by about 10 to 30%. In Missouri, they got about the same results, 20 to 25% increase in survival. Those are pretty good increases considering the rates of survival before that were in 60-ish%. So improvement is definitely needed. They did another study in Missouri, so it's not suitable for all sites, where they only got a 4% rip. And I have to identify this study as well by Kuchla down in Mississippi. He didn't see any benefit. However, that was a machine planted field, and the coulter on the planting machine was about the same depth as the ripping shank, so the two couldn't necessarily be compared. That's kind of where that discrepancy comes from. If we look at growth, again, we see good results. 50% increases in diameter growth, increased levels of height growth, more free to grow trees. And some of these effects have actually been long term. On this one study by Gwazi, the effects actually went away after about 16 years, but on another site in Missouri, 20 years later, they were still seeing the positive effects of ripping. Again, Kuchla didn't find any significant differences, but it's because the shanks were the same size. I'm going to skip that to save time. It can be harsh on the site, however, it has a couple of really good growth and survival advantages we should probably consider. Site preparation, using herbicides. This is the one that, at least locally, we have had really good luck with. Using site preparation herbicides to knock back that competition for an extended period of time seems to be something that needs to be a part of our regeneration plans for shortleaf pine. However, also, again, acknowledging that conservation goals sometimes would steer us away from something like a broadcast application of herbicides, there are other options that we could look at where we still get to maintain some hardwood component or component of desirable hardwoods, as well as herbaceous ground cover, while still regenerating shortleaf on these sites. So banded applications, spot treatments, directed sprays, these are all options. We don't always just have to have a helicopter come over and fly over and drop the herbicides. I realize that's the most cost-effective way most of the time, but for some of our broader goals, we need to remember that these are also options that we can employ on the landscape. The research that's come back has been pretty clear. Increasing or using herbicides for site preparation has increased both growth and survival, and that's all across the range. This study's from, I believe, Arkansas or Louisiana. This is from Mississippi. This is somewhere in Southside Virginia. You need to use some herbicides. I mean, or you don't need to. On most sites, you're going to ultimately need to use some herbicides unless you've been really good about using fire for the last couple of decades. The thing that I would point out, though, is make sure you read the herbicide label. Again, it's not loblolly pine. It's different. If you look at the release rates for, let's use Arsenal, for example. For shortleaf pine, it's only 12 to 16 fluid ounces per acre, whereas for shortleaf pine, it's 16 to 20. So if you use a shortleaf mix, you risk torching your shortleaf, or if you use a loblolly mixture, you risk torching your shortleaf pine. And shortleaf's not even listed as a species that can be released or I guess basically just sprayed over for many of the other herbicides that are out there. So be sure to check your herbicide label. It'd actually be worthwhile if somebody went in and made an herbicide guide for shortleaf locally. Site preparation, burning, again, you're going to hear a lot about fire right after me, so I don't want to touch on this. Most of the stuff that we've done locally in North Carolina, fire has been a pretty key component in reducing the slash and giving the planting crew room to work, as well as temporary reduction of the herbaceous competition and woody competition. So now that you've prepared your site, we're going to talk a little bit about planting stock. And I know the question about improvement came up. That's going to be addressed later on, I believe, during the panel. But I'll talk a little bit about stock types. You pretty much have two to pick from here in North Carolina. You could do some direct seeding. I'm not really going to talk about that. The research has been kind of spotty on it. But if you're planting, you have your bare root and your containerized stock. Bare root trees have their plus side. They tend to be cheaper all around, cheaper to produce, transport, and plant, therefore cheaper out of your pocket. However, they are more susceptible to drought, poor handling, as well as root damage during the lifting process. There's also research pointing out that these things really can't last that long from the lifting date. Once you lift them, you pretty much have to get them in the ground in a few weeks or your survival is going to plummet. I don't remember the exact date. James, do you remember? What's the, how long can you store these things? It's like 4 weeks, right?
Depends on who you ask. With proper chilling, it appears that they can store similar to loblolly.
Okay. Well, that's new. But when we look at containerized stuff, it tends to be more expensive. It's harder to transport. It's a bulkier seedling, harder to plant. I typically end up having to pay my planting contractor more to plant this stuff. However, it has a more intact root system, tends to have greater root mass. And what that translates into is it'll often outgrow and outsurvive bare root stock on the same site. And I have some research later to show that we've actually found that result locally as well as other places. It also, you have an extended planting and storage window. You can plant these things in the fall, you can plant them in the spring. Containerized seedlings really just open up a lot of options. I can tell you, we don't even plant bare root stuff on research station properties anymore. It's all containerized because of the superiority of them. So regeneration methods. I'm only going to touch on two. I'm assuming most people are acquainted with the concepts of coming in and planting over a cutover with bare root or containerized trees. So I'm not going to spend any time on that. I'm going to instead spend some time looking at regenerating mixed stands and some of the stuff that's been developed on how to do that that might be applicable for our area. The fell and burn technique. I've heard this referred to as kind of an old school technique. I admittedly haven't seen it practiced in about 10 years in this way. That being said, I understand that UARI has done some of this stuff in the past, although it's a slightly different variation of which one I'm presenting here. But basically what this consists of is you go in, you do a total harvest in the stand. You then wait for things to sprout back, both your hardwoods and your pines. Once that stuff is sprouted back, I'd probably give it to about waist high. You wait until April for it to leaf out. Then you come in with brush saws, you cut all that down. That stuff lays on the ground, it has leaves. It'll start to dry out, so you have this thatch work of fuel that's probably going to be capable of carrying a fire at that point. Because you harvested in April, all that stuff you cut is throwing up new shoots, and that's growing right into that thatch work. So come summertime, you rip a hot fire through that thing, and you really knock back a lot of that hardwood that's come up underneath it. So that's your classic fell and burn. Once you've burned through it, you then come in and plant the pine species of your choice, which can be shortleaf pine. And they've actually done this in this area, or at least in this region of the country. So Phillips and Abercrombie did it down in South Carolina. They had pretty good results. They ended up with 68 to 92% survival in a mixed stand, and the mixed stands that were left over actually had a lot of hardwood species that you might want on that stand, like oak. So that has been successful. They also did it with loblolly pine down in the Piedmont of Georgia, and again ended up with adequate survival rates, 54 to 74%. But keep in mind, we're trying to go for a mixed stand here. So lower survival rates, while wasteful, depending on what hardwood species come back, and if you were to couple this with some herbicide treatments to really ensure what comes back is what you want, this is an adequate way to come back and regenerate these stands. Underplanting is another one of those methods that we've been looking at locally, and they've done a fair bit of work on out in the western part of Shortleaf Pine's range. Textbook definition, artificially regenerating an age class of trees beneath a residual hardwood or a residual overstory. Doesn't necessarily have to be hardwood. You can underplant beneath other pine trees. It's not a whole lot different than coming in and controlling the rate of establishment and density of establishment underneath a reproduction cut. You're just doing it on your own terms. So it's a suitable option where the aesthetic values tend to outweigh your timber production values because the research is clear. It knocks back the growth. And it's also desirable in areas where your overstory might be, required or just beneficial to the landowner. They may not want to get rid of all their mast growing trees. And there's a picture of our site in Durham County. So the research, there's actually been 4 studies out in the western part of the range, and they've all pretty much come up with the same thing. There's an inverse relationship between overstory retention and underplant seedling growth. So the more overstory you leave, the slower the trees grow. However, in the lower residual basal areas, those trees are still growing. It's kind of up to you and kind of up to the landowner to figure out at what threshold it no longer makes sense to do this. What I can tell you is under 15 square feet, on our sites in North Carolina, we're not seeing a whole lot of difference between that and the clear-cut plots. So here's the study we've done in North Carolina. These results will be available, I don't know, a couple of months. We did this up in Durham County. We actually replicated 4 different treatments, 15, 0, and 30, 45 square feet, and then underplanted both containerized and bare root shortleaf pine beneath those, and we've been tracking them for 2 years. Didn't do any chemical control, but we did burn a hot fire through it before planting. What we found is that the survival is actually lowest in the clear-cut plot, and that kind of goes back to what we saw on some of the other sites. It's a harsh climate. It's really hot in those clear-cuts. It's also full of herbaceous competition. So in our clear-cut plots, seedlings really didn't do well. We had 40% survival for our bare root stock underneath those conditions. It was a harsh, dry site, nice for shortleaf. But we actually lost that. Once we put a little bit of cover on the landscape, survival actually equaled out. We didn't have any statistically significant differences between them. When we looked at the growth, we again found that inverse relationship, but it was less defined than the previous studies. That being said, I'm only looking at 2-year results right now. Those other studies have been going for 7. Wouldn't be surprised if things kind of space themselves out a little bit more over time. But the 15 and the 0 square foot plots, pretty good growth. Honestly, no significant differences between them. When we looked at specific interactions, 15, at least early on, was doing better than the 0 square foot plots, again attributed to that kind of harsh condition and nasty stuff. But the 30 and 45 square foot plots, it's pretty shady in there. That is actually a 45 square foot plot there. So you can see it's not great light conditions in there. Actually, that might be a 30. I think it's 45. The other thing I wanted to point out here is, again, we planted both containerized and bare root stock. Just to throw some numbers your way, we ended up with, on the low end, 40% survival in the clear-cut plots, but it averaged out across all treatments to about 60% survival for bare root stock, which is not a whole lot different than what they were finding back in Arkansas and Missouri, back when they launched the efforts to find some information on regenerating this stuff. With our containerized stock, we planted 2 kinds. One was grown by North Carolina Forest Service, the other was grown by a private vendor. North Carolina Forest Service, 99% survival after 1 growing season. We unfortunately had some insect damage and deer damage come, so we can't really present you 2-year results, but 99% survival. That's across all treatments. We did not have that effect with the 0 square foot being lower. We didn't find that in those seedlings. Likewise, the other private vendor containerized stock that we planted, it was a very subtle difference underneath the 0 square foot plot. Other than that, we still saw about 92% survival for those. So I'd gladly take over 90% survival for shortleaf any day. My takeaway from this is I would strongly recommend you give a hard look at spending the extra couple of bucks and put containerized shortleaf in the ground. So, as a recap of what I've presented here, shortleaf can be regenerated. This concept of, oh, we don't know enough about shortleaf pine to regenerate it, it's simply not true. We actually know a lot about regenerating shortleaf pine. There's a lot of information out there. If you dig, you'll find it. Those proceedings on the handout, the references are all in the back. You can look that up. There's hundreds of pages of regenerating shortleaf pine out there. Check it out. We need to start trying it locally, though, to make sure some of those techniques actually do transfer over to our region of the country. But the methods need to be picked based on landowner objectives. Also, don't force it. Mike touched on this earlier. Don't plant it on a little leaf site. Don't plant it on a floodplain that has overstory loblolly pine. Don't plant it on a site that has 2,000 red maple stems per acre if you're unwilling to use herbicides to try to control those. You're just going to be fighting other species the entire time. So plant it where it makes sense and where it has the potential to maintain dominance. Natural regeneration, I just want to point out, it has some major hurdles. With smoke management issues in this area, there are areas where it can work. By all means, if you have an area where you think you can retain enough healthy shortleaf to actually regenerate this stuff, more power to you. Try it out. And let me know if you do it, because I want to come see. But it has some major hurdles in some of our other areas, like around Durham County, where we manage a lot of shortleaf. That's a tough thing to do there. Many of my stands, I just don't even have enough of it left to regenerate. Many places in North Carolina will therefore really need to be artificially regenerated. But again, I'm not suggesting we put huge plantations of this stuff out there. Site preparation is key. You need to put the time into site prep, and you need to put your time into release. It's essential, especially in this area that's based on both operational looks at growing shortleaf pine around here, as well as the literature on regenerating shortleaf. Oftentimes, though, it's combinations. So it's not just one method that you need to employ. We need to actually pull out a whole bunch of different methods and put those on the landscape. Combinations tend to work really well. So the spray, burn, plant is a good one. Burn, rip, plant, spray. If you actually want to ride on a D8 and try to rip a clear cut, which I'm not going to do, but some people might want to try that out. So that's another option. And finally, regenerating mixed stands, it's possible, but we still have a lot to know, or a lot to learn about it. We need to start trying some of these things out locally. We need to start trying to do some shelterwood that are mixtures of shortleaf pine, oak, and hickory, or other associated species, and figure out what light levels are necessary to result in adequate regeneration, and start getting that information out to everybody else too. Because we don't have a lot of the answers right now necessary to move forward with some of this, but that's not to say we shouldn't start trying some of it. So we have some quantified numbers. We could use a little more. Underplanting seems to work pretty well, but again, it gets suppressed when you get up in higher basal areas. So if you're going to do underplanting, don't leave too much on top. And light levels, that's the big thing. We need to take a look at that locally, because you can't do apples to apples. And I've actually seen it done. I've seen people, oh, okay, well, I'm going to do this. I'm going to leave 40 square feet of oak. That's a lot of shade. You're not going to get shortleaf pine underneath that. And our underplanting also suggests that it pretty much hasn't grown in 2 years underneath 45 square feet. So realize that was kind of a whirlwind, but I don't think I have time for questions. But here's our attempt at starting to regenerate some shortleaf up in, that's actually in Granville County. So if I have time, I'll take one or two, but I don't think I do. Anything? All right, good.